Hello everyone, welcome to my YouTube channel Nafiz Learner Zone. This video I'm going to continue about the electricity, that is part 2. Then the part 1 we studied about charge and the current. So today we are going to learn about the potential difference and the relationship between the current and the potential difference. So first thing we have to understand what is potential difference. You already learned about what is potential. Potential in your ninth standard, you studied kinetic energy, potential energy, potential. What do you mean by potential? Whenever there is something called as potential comes, there might be your teachers or somebody might have told you you have a lot of potential. What is that potential? Potential is something which is stored, which can be used, but it is not being used. That is potential. So what is potential and what is potential difference? Let's look in detail in this video. We have studied an example of potential energy, that is water stored in the dams. So when you store water in the dams, it contains potential energy. Suppose I have a bottle here. You can see the water flowing inside. It is half filled. The bottle is half filled. So what happens is the potential. So the potential at the right side of the bottle and the left side of the bottle is almost same here. So you can see the water is not flowing. There is just a little movement. So what happens if there is some change? So you can check out, if I tilt this bottle, the water from this end moves to the other end. Why? There is a difference in the potential. So here, because we have lifted it up, so what potential energy has increased here, and here it was less. Because of the difference in the potential, water moved from this point to this point. If I change this again, so you can check out, it moves. It's a simple thing which you all know it. So but this is what is the difference in the potential by which a water moves. So same way, even in current also the same thing happens. So the potential, you do it in your homes, something water. Let's take another example, that you lift water from the motor, that needs energy. But when water is been flowing from the top floor to the ground floor, it doesn't need energy. What happens is there is a potential created. Due to the difference, it moves. So like that, even in the current, there is, even along with the current what we study, the electricity, there is a component called as potential difference. So what is that? Let's take, this is a metallic wire in front of you. So you can see that this is a iron wire. So what happens is, you know that metals are good conductor of electricity. What happens here is, if the current has to move, you studied yesterday that what is current? The flow of charges from one point to the other in the given time. So rate of flow of charges, current. So how does the charges flow? If a charge has to flow, there should be a difference in the potential, as we seen in the example of the water. So if this end and this end, if we name this end as A and this end as B, in between these two ends, if there is difference in the potential, then only the charges can flow. In the sense, you can check out in the slide beside, so that there are here the charges, the charges will be different, and here it is different. So potential at A and potential at B, if it is different, then the difference between that, so if we take this as V1 and if we take this as V2, the difference between these V2 minus V1 will be the potential difference. We define potential difference. We define potential difference as the work done to move a unit charge from one point to the other point. It might be from infinity to the particular point, or it might be from point A to point B, as I showed you. So in this wire, if this is A and this is B, so here there are charges. So we have to move this charge from point A to point B. So if we have to move something, you know that work has to be done. You studied in the ninth standard, work done. So that work done to move a unit charge, particular charge, from one point to the other point is known as potential difference. We represent potential difference with the letter V, stands for voltage. Hope you may know about voltage. We study about different voltage, as we have different voltage device, like 9 volt battery you might have seen, 12 volt battery you might have seen. So many different voltage, and our domestic electric circuit will be having 220 volt. That is the voltage of that. Many times you might have heard about the voltage of different devices. So different devices will be having different voltage. So that voltage is itself nothing but the potential difference. Okay, so that we are going to study now. So V, from which what we represent is V, and the unit also is V, that stands for volt. Volt. Okay, volt is the unit of voltage or the potential difference. So exact term is potential difference. In common we can call it as voltage also. So as I told you, the definition of the potential difference is the work done to move a unit charge from one point to the other point. Then how do we represent it mathematically? So mathematically we write it as V is equal to W by Q. So what is this? V stands for voltage, as I already told you. And what is W? In 9th standard you have studied, that is work done. So work done divided by Q. Q in the previous video we had discussed, that is charge. So potential difference is equal to work done to move a unit charge. Okay. So rate of work done with respect to charge, not with respect to time, with respect to charge, that is V is equal to W by Q. This is the mathematical definition of potential difference. Okay, right. So the next thing is, how do we measure the potential difference of a circuit? Like in previous video we had discussed about how do we measure current. We measure current by using a device called as ammeter. How do we measure the potential difference or the voltage of the circuit? We measure it by using another device known as voltmeter. Okay, volt, V-O-L-T, voltmeter, not voltameter. There is a separate device called as voltameter, which you learn it in chemistry. Don't call it voltmeter, it is voltmeter. Okay, right? So that is and as we discussed in the previous video, how ammeter should be connected in a circuit, that's an important question. Same way, even how voltmeter should be connected in a circuit and why, that is also an important question. Together it may come. So voltmeter, as ammeter is always connected in series, voltmeter should always be connected in parallel. In parallel with in which the points between which we are measuring the potential difference, measuring the voltage. So the 2 points, as I had showed you about this conductor, if you want to measure the potential difference from this point and this point, a voltmeter should be connected parallel to this. Okay, you can check out in the slide above that how it is connected in a circuit. Okay, so why it should be connected in parallel? Why it should be connected? Why ammeter should be connected in series? Same way, why voltmeter should be connected in parallel? That is because voltmeter required high resistance, as it is not measuring the current. It is measuring the potential difference, so it doesn't require current. Current should be resisted. So because it required high resistance, it will be connected in parallel to the circuit, right? So what is resistance? That we'll study further when we study the relation between current and the potential difference. Okay, so we should understand what is 1 volt, like a definition which can be asked in your exam, like what is 1 ampere we had discussed today. What is 1 volt? The 1 volt quantity is when 1 joule of work is done to move 1 coulomb of charge, that is known as 1 volt. As we know that mathematically V is equal to W by Q. So if 1 volt, if V should be 1, then that is 1 work done. In the sense, work done we measure in joules. So if 1 joule of work is being done to move 1 coulomb of charge from one point to the other point, then that is said to be 1 volt. Then from that you can think about what is 220 volt, what is 9 volt battery and all those. You can just get it done. So how much work is done to move the charge and everything from that. So 1 volt is defined as 1 coulomb of charge to move. It required 1 joule of work to be done. Fine. Before going for the relationship between the current and the potential difference, we should understand an electrical circuit. and what are its components, and from what symbol it is represented. So you have learnt it in your 7th, 8th, in the previous classes, so I will not go in detail about that. You have to just remember the symbol and how it is connected. So you can look at the slide here. So you have an electric circuit, and the things which are connected, what is the symbol of battery, you can check out, cell, the voltmeter, ammeter, so resistors, all these things, and further whatever the things are there, electrical components, what are its symbol, you can just go through, you can make note of it. This is important to write down a circuit from this chapter. Further, it will be helpful in solving some problems also related to the formulas, everything, the relationship between the current and the potential difference. We'll discuss in the next video, as this video had become longer. So we'll discuss, I had told you we'll discuss in this video, but we'll discuss in the next video about the different relationship between current and the potential difference. That is a very, very important video. Don't miss that. Okay, so from this video I am going to post some questions for solving on recommendation of one of our viewer, one of the student and the parent. So I am posting some questions, hope you guys will solve it and show me those things. You can post that to my number, that images what you are working out. I will show it in my next videos about how my students are working. Okay, fine. So that's it from today. Thank you so much for watching. If you are having any queries, write it down in the comments below. Please like, subscribe and share my video. Thank you.